Welcome to one of 5 mini-lectures for final year civil engineering students on the topic of geosynthetics. We aim to assist students in civil engineering and geotechnical engineers in understanding more about geosynthetics, which have emerged as a common solution in civil engineering projects over the past 50 years. With a basic understanding of geosynthetics, engineers are better placed to understand the applications, functions, design considerations, and the various geosynthetic product categories. This program was funded by the International Fibre Centre and developed by Monash Geomechanics Group at Monash University in conjunction with the Technical Textiles and Non-Wovens Association. The program consists of 7 mini-lectures over 3 years of the engineering course, from 2nd to 4th year. It moves from an introductory discussion through an intermediate stage in 3rd year, before focusing during 4th year on some common functions and applications. This unit is aimed at final year civil engineering students. In this unit, we look at the largest product category of geosynthetics, that is, geotextiles. Geotextiles are textiles in the traditional sense. Fibres are made into flexible porous fabrics by standard weaving or knitting machinery, or matted together in a random non-woven manner. Today, we will focus only on geotextiles made from synthetic fibres. These geotextiles allow liquids to flow through whilst retaining fine materials such as soil particles. Before looking at geotextiles in detail, let's review what we learnt in Level 2 Civil Engineering. Geotextiles are the major category of geosynthetics. They are used in nearly every highway project and can be found in almost all civil construction works. Throughout history, engineers have needed to deal with the problem of building on weak soils. Many different solutions have been used. Since the mid-20th century, geotextiles have emerged as a simple, cost-effective building option for engineers. An early use of man-made materials to improve soil performance is believed to date back to the 21st century BC in the construction of the ziggurat in Iraq. Geotextiles perform several functions, from reinforcement and separation beneath roads and embankments to filtration in subsoil drains and behind rock seawalls. To refresh ourselves about how geotextiles are used, let's look at a few of the most common applications. A high-strength geotextile provides reinforcement for weak soils under an embankment. A lightweight non-woven geotextile is being applied to a road surface to reduce water ingress and thus reducing cracking of the surface. A non-woven geotextile is simply being used to protect a sporting surface from temporary staging for a concert. Geotextiles are used widely in landfills and waste containment to provide drainage and protect the lining system from puncture. In this instance, a tailings dam wall is built from existing soil and rock. The geotextile acts as a filtration layer, holding the tailings inside the dam while allowing the water content to filter out. Coastal applications using geotextiles are emerging as a novel solution to beach erosion. In this unit, we cover applications, manufacturing processes, raw materials, product specification and selection, quality assurance. First, let's look at the common applications of geotextiles. The most common applications for geotextiles are in roads, railways, landfills, and coastal works. In all these areas, they are used in conjunction with soil to provide additional strength, prevent contamination of good quality fill material, allow the passage of water whilst retaining the drained soil particles, prevent damage to plastic liners, form flexible containers for coastal protection. In roads and railways, a solid formation is always required. Uneven settlement of the carriageway will lead to undulations or a breakdown of the surface. The traditional method of providing a uniform base is excavation and importation of aggregate. This can be expensive in materials and time. Geotextiles are often used at the base of roads and railways. They can significantly reduce the required depth of excavation, particularly when traversing poor quality soils. Geotextiles provide strength. They prevent the underlying soil from contamination from the imported aggregate. This increases durability of the structure. It is important to keep moisture content in the formation low. This extends the pavement life. Geotextiles are used in subsurface drains to allow moisture to drain out of the formation. Geotextiles are also used to seal and reinforce the surface of aging pavements. Geotextiles can make a big difference when working on weak soils. The classic use of a geotextile is at the base of a road formation. As well as separating the weak soil from the introduced road aggregate, the geotextile allows water to drain from the road formation. Geotextiles can be found in combination with geogrids or other geosynthetics on extremely weak or waterlogged soils. They are also used in other civil infrastructure, in this case a bridge abutment. The geotextile is placed underneath a geocell to protect the abutment during flood conditions. A geotextile separation layer is often used in railway formations. They are even rolled out under existing railways. The geotextile provides a separate function. The geogrid provides reinforcement by interacting with the rail ballast, which is yet to be placed. Modern landfill structures are designed with sophisticated containment systems. They ensure the waste remains separated from the surrounding environment. Engineers must ensure this separation, both during the work life of the dump and long after it has been decommissioned. Low permeability liners, that is, geomembranes and geosynthetic clay liners, are often used. If these products are punctured, hazardous leachate will escape into the surrounding groundwater. Geotextile layers above and below the non-porous liner mitigates the risk of puncture. They provide protection from sharp-edged waste material as well as the base underneath. Geotextiles are also used in the leachate collection system of landfills. During its working life, the landfill will be open to rainfall. As the water filters through the waste, it creates leachate that collects at the bottom of the landfill. Leachate collection systems are designed to control the movement of this hazardous liquid within the landfill. Geotextiles are used as a filter layer. They allow the leachate to pass through while preventing fine materials from entering and clogging the leachate collection system.